start. So it is day 17 today. It is Tuesday, February 11th. So we have been graphing equations, we've been graphing inequalities, and just yesterday we started looking at systems of equations, which luckily for us is not too difficult because we already know how to graph equations. So a system is just putting two equations on one graph. That's really all there is to it. So let's just start from the very beginning at number 1, where I have the equations y equals 2/3 x plus 1 and y equals negative x plus 6. So I always like to start with identifying my y-intercept and my slope. So who can tell me what are my y-intercepts and my slopes? 1 for my first equation. Good, that's my y-intercept. And what's the slope of that equation? That's all right. I know what you mean. 2/3. We got it. 2/3. Okay, so let's graph one line at a time so we don't accidentally connect the wrong dots. So if my y-intercept is 1, where do I put my first point? 1 on the y-axis, which I guess I forgot to label on this worksheet. Sorry, guys. Okay, and that's our starting point. Where do I go from there?
Up to.
Perfect, up to.
And then 3.
1, 2, 3. Just like that. So there's my first line. And I'm going to connect the dots. Beautiful thing about equations is it's always a solid line because it's equal to. We're not looking at greater than, less than. No dotted lines needed. No shading either. Okay, so there is my first line graphed. So somebody guide me through how am I going to graph my second line? 6 is my y-intercept. Okay, so I'm going to just label that. Yes, and then since I have negative x, that means my slope is negative 1. So negative 1 over 1 if we wanted to think of it like a fraction. Okay, so where's my starting point? 6. All the way up there on the y-axis. And where do I go from there? Perfect. Down 1 and over 1. So there's my two dots. I could go ahead and connect them there, but sometimes with these slopes that are really small, like negative 1, I like to continue my slope and keep going down 1 over 1 just to give me a more accurate line. This, of course, is optional, but it might help give you a more accurate drawing. And in this case, as I go and do that, I see it's going to cross through this point here. So I'm going to connect these dots. Just like this. And are we done?
No.
What are we missing? There's one more thing.
You gotta do your, what the connect number is.
Yes, the number where these lines connect. So the only thing different about a system of equations is there is also a solution to the system. And when we're finding the solution, we're finding where the lines cross. We're also finding which number can I plug in for x and y in both of these equations that works for both of them. And that is going to be this point here. So what is the coordinate of that point?
3.
3 for x or y? Both! It is for both. I see that on the x-axis I am lined up with 3. That's my x. And same for y. I'm lining up with 3 on the y. So this is our solution, 3, 3. This is our graph. Any questions about number 1? Did everybody get that one okay? Awesome. Did anyone forget to mark your solution? Maybe if you hadn't known about the solution yet, maybe you hadn't done it, but I think at this point all we just got to know is it's where it crosses. We check for the points, and it's just one more little step. So that's great. Okay, let's go on to number 2. This one's a little bit of a challenge because our equations are not as typical as our first problem. We've got some pretty easy to read slope-intercept form. Y equals mx plus b. Over in number 2 though, I have y equals mx, y equals 3x, that's what that is. And then I have y equals, there's no x, minus 3. So y equals 3x and y equals negative 3. Which one of these equations do we want to try to graph first? The x one? Okay, so y equals 3x. So when we graph this equation, what are some things we should think about first? What should we look for? How do we know what to graph it as?
Add a number.
Add a number, like to the end of the equation?
Yeah.
Okay, so I have y equals 3x and then write plus.
Plus whatever number.
Okay, what number would this be?
4, 5.
Zero? It'd be 0. It'd be 0. Because if I have this equation, y equals mx plus b, right, where m is my slope, so 3, and b is my y-intercept, if there is no number here for b, and there's not a letter b, that means b must be 0. Because if it has disappeared, it is gone. The only number with the power to make something disappear is 0. So we can assume that there is an invisible 0 there. Another way that we can think of this, because sometimes it's hard to remember, when do I know it's plus 0? I like to think of, I'm actually going to pull out a separate piece of paper. You don't need to take notes on this unless you find it super helpful, but I'm just going to show you something that I think will help a little. Let me grab a empty piece of graph paper. Okay, so I'm going to give you a mini lesson on the theory behind algebra, so feel free to just watch. You don't have to write it. I'm not going to test you on this. But whenever we have an equation like y equals mx plus b, okay, remember we know our b is our y-intercept. And the y-intercept is our starting point, right? It tells us how high to move the equation up on the line. So what I'm going to show you here is something called a parent function. You don't need to know this, but I think it's interesting. The parent function of this equation here is y equals x. Okay, and I'm going to show you how to graph this. When y equals x, that means whatever my y value is, my x value is the same. So if I, for example, have 0 for x, my y is also 0. If I have 1 for x, I have 1 for y. Negative 3 for x, negative 3 for y. This means that my y is the same as my x. If I were to graph that, it would look like this. It would look like a perfect line going straight through 0, just like this. And again, I'm not testing you on this. I'm just showing it to you. Okay, so this is what we call a parent function. This is like the original function. There's not a number for slope other than 1, because there's that invisible 1. There's no number for b. There's no plus something. This is the original equation we start with. When I start adding numbers to the end, such as, let's say I do y equals x plus 2. If this were my y-intercept, then all that's happening is I'm taking this line that is my quote-unquote parent function and I'm moving it up 2 because this is my y-intercept. I start at 2. My slope is 1, so it's up 1 over 1, up 1 over 1, up 1 over 1. We're going to get a line that looks like this. Okay, so looking at it this way, we know that the number at the end of the equation, the plus something or the minus something, it just tells us how high or low to move the line where it touches on the y-axis, going up and down. So we can assume that since our parent function, y equals x, there's no plus anything, that's technically plus 0. It just means that our starting point is 0. We only have a starting point up something or down something if there's a number at the end of the equation telling us to do that. So for example, in this equation that we graphed previously, we had y equals 2/3 x plus 1. The only reason we didn't start at 0 and use our slope is because it said plus 1 at the end of the equation. If it was y equals 2/3 x, we would have started at 0, and then we would have done up 2 over 3. So, keeping all of that in mind now, look at number 2, and I have an equation that says y equals 3x. Because there's not a plus something or a minus something, we know that our starting point, the first spot that we start on for this equation, is just going to be at 0. Our starting point is 0 unless it tells us to do something different with the b. So we have y equals 3x plus 0, and hopefully that, maybe it connected some dots for some of you in your brains. Maybe it totally confused some of you. But it is something that we can think about. It's not something I'm going to test you on though, so don't worry if you're a little lost there. But let me ask everybody this. Do we understand why we're starting at 0, why our y-intercept is 0 for y equals 3x? We got that? Okay. Okay, awesome. If at any point you decide that that doesn't make sense to you, just let me know. We can talk about it. So we've got our y-intercept for this equation, y equals 3x. What is our slope? It's 3 over 1. Perfect. Our number next to x, the m, is 3. So it's 3 over 1. So where do I go to find my second point?
Go up 3.
Perfect. I'm going to go up 1, 2, 3,
And then 1.
and over 1. Okay, so there is my first equation. Beautiful. And this one's also tricky because your second equation, I'm going to rewrite it because I wrote the word challenge over it and it kind of messed up the y. It's just y equals -3. How would we graph this, y equals -3?
Plus 0.
Plus 0?
Right? No.
So we know that it's plus 0 if we have a slope. My slope is 3x. There's no x next to this number, so technically this is our b. This is like our y-intercept, right?
It'll be 1.
What would be 1?
I don't know.
Do you just go down to -3 on the y-intercept, and then
Yes.
it's going to be straight up and down from 0?
So let's see. We have y equals -3. So when you have an equation like this, first of all, if our equation is y equals mx plus b, if our slope was 1, I'm going to address what you said, Lisa, and then I'm going to get to what you just said, Amanda. If our slope was 1 here, that means we would have x minus 3. But there's no x at all, none. So if there is, what is the number that has the power to make a variable disappear that we just talked about right up here? What number could x be? 0. It's 0. So this does not have a slope. There's no m, so there's no x. This is our b, which is our y-intercept, which you just said, Amanda, that's absolutely correct. We're going to start at y equals -3. So I'm going to go on the y-axis down to -1, 2, 3. And that is my starting point. Now, what happens when we don't have a slope? Well, it's not just a point. What does an equation mean whenever I have y equals -3?
It can be any number.
It can be any number.
Y-intercept,
Say that one more time.
any number along the the y-intercept, because it's going to be a straight line, and your meeting point is going to be 0.
So it is going to be -3 on the y-axis. I think you're thinking of the x can be any number. Because here's what happens. Let me give you guys a quick little reminder. We talked about this yesterday a little bit. When we have an equation that just says y equals a number or x equals a number, in this case we have y, that just means no matter where I make a point on the graph, my y value is always -3. So right here I already did, let's see, this would be 0 for x, -3 for y. Okay. Where could I put another point? You could put it in a lot of different places. Remember, this is our x, this is our y. Our equation is y equals -3.
Put it next to the 3 again?
Next to the 3, the -3, what do you mean, like to the right or left?
To the right.
Either one? Yeah, you could put one here, absolutely. What would this coordinate be?
It'd be
1 -3. What's the pattern you notice already?
3.
-3 is always going to be our value for y. So remember, anytime we have an equation that's just y equals a number, it's going to be as many points as you want. The x value can be any number you want. Your y is always -3 because it tells us this right here. Y is -3, always. So I could choose x as -5. What's my y? -3, always. If my x was 6, what would my y be? -3. And you're going to notice we're going to end up with a straight line going left to right horizontally. Now, if you guys pull out that worksheet we did yesterday with a bunch of examples like this, that might not be a bad thing to keep out and around. And I'll pull mine out just to show you what I mean. Let me pause this while I grab it so it's not just empty space. Hang on. Okay, so here's the worksheets that I am referring to from yesterday. Let me get that to focus. We have a graph paper full of y equals, and these are inequalities, but it's the same concept. I've got, for example, y equals 2. That would be a straight line going through 2 on the y-axis. Y equals -3. That's actually the same one we just did. See that? It goes through -3 on the y-axis. Y is negative 2, negative 2 on the y-axis. Y is negative 4, negative 4 on the y-axis. You guys see that? So yes, go ahead.
Sorry.
No, go.
I got everything right, and I plotted my point on the -3, but what I didn't understand is the solution. Is the solution 0, -3?
Oh, that's a very good question. So remember our solution, and let's make a note of this because this is super easy to mix up. I'm going to write this at the top of my paper. The solution, because this goes for every problem, is the intersection. It's where the lines cross. So then we'll look at this one. Oops. So if I have like lines like this, it's whatever the point is where they are crossing each other.
Okay.
So where do these lines cross?
Is it -1, 3?
Negative 1 and negative 3. Yes. So I'm going to mark that. This is my intersection. This is where the lines are crossing. And I'm going to circle it.
That's what threw me off because I was looking for the dot.
Oh, I gotcha. Yes, and I know the ones that we did yesterday, they all very conveniently lined up on a dot. Sometimes they don't. This one doesn't, but luckily it still does give us a pretty nice, neat point there. So this would be our x value. It lines up with -1 on the x-axis and -3 on the y-axis. So that would be our solution. Okay. Does that make a little more sense to everybody? Okay. Awesome. Awesome, awesome. Do we have any questions about number 2? I know that one was tricky. That was a tough one. Okay, well, let's go to number 3 then. Back to some more normal looking ones. Let me move this actually, my light's being a little bit funny. Okay, so in this problem, I have 2 equations with pretty similar slopes. Y equals -3 over 4x plus 2, y equals +3 over 4x minus 4. So, who can help me graph my first equation?
Your y-intercept is 2.
Perfect. My y-intercept is 2, so I'll go ahead and put a 2 on my y-axis.
Slope is -3/4.
Perfect. Slope right here, -3/4. So how do I get to my second point on this line?
You are going to go down to -3 and then over 4.
Perfect. So I'll go down 1, 2, 3, and over to the right 1, 2, 3, 4. So there is my next point at 4, -1, right there. And let's go ahead and connect those dots. Okay. So there is our first equation graphed. How about the next one?
Your first point is going to be on negative, your y-intercept is -4.
Perfect. My y-intercept and my first point, -4.
And your slope is 3/4.
Perfect. My slope is 3/4. So we go up 1, 2, 3 over 1, 2, 3, and 4. And that one lands right on the second point of our first equation. That gives us an easier intersection. So I'm going to connect my dots. So, what is our solution?
4 -1.
Yes, it is the intersection here over 4 on the x-axis, down 1, -1 on the y-axis. So my x is 4, my y is -1. Very good. Very good. Okay, any questions on number 3? Okay, let's look at number 4. Here's another challenge. Now this one's challenging in terms of graphing just because it's unfamiliar compared to the other ones. But the solution, this will actually be your easiest one to find. So, when x is 4 and y is 3, before we graph this, does anybody know what the solution is? It's 4, 3. Whenever we have two equations where all they give us is x equals 4, y equals 3, that's going to be our solution. They gave us an x value and they gave us a y value. And I'm going to show you why when we make our graph. You'll see that, oh, yeah, that makes sense. So x is 4, y is 3. That is our solution. Now let's graph these equations and make sure that's right. So, how do I graph x equals 4? Did you say 0, 4? 0, 4. Do you mean go up 0 over 4? What do you mean by that?
So y 0.
Okay. Over 4 on the x-axis? Yeah. Okay, so if it says x equals 4, a good first step is to find 4 on the x-axis. And let's just mark a point there. X equals 4. And just like in number 2, whenever you have an equation that's just y equals something or x equals something, what does this mean about all the other points? When x equals 4, what are my points going to be looking like? Hi, Jenny.
I can't see.
Oh. Here, I'm going to pause this real quick, actually. Okay, so unpausing. Let's get back to that question. We're on number 4, and we are graphing x equals 4. We started by plotting a point on the x-axis at 4 because x equals 4. So, can somebody explain to me, I'm going to ask again, I think Seth, you might have been starting to answer for me. What do we need to be thinking about? What's our next steps? How are we going to graph the line x equals 4?
So you don't have the y-intercept, so it's just 0.
Yes, we don't have a y-intercept, so it could just be 0. Is there a y-intercept though? Let's see. So our y is 3, that's right. But we're just thinking about our x equals 4. How do we graph that line? When we have x equals a number, what does that line look like?
It's just
Straight? Is it straight side to side or straight up and down?
side to side.
So our y equals line was side to side.
So it's up and down.
So it's up and down, yes. So remember when x equals 4, let's go back to reviewing what we can do instead of thinking of y-intercept and slope. If I wanted to write some coordinates for x equals 4. Okay, so because the equation is x equals 4, what should my x be for both of these coordinates? 4. My x is always going to be 4. We just graphed 4, 0. Can we think of 2 more points? Does it matter what my y is? No. It can be anything. So give me 2 random numbers. How about a positive and a negative?
Positive 6.
Okay, here I heard 3 and then I heard positive 6. I'll do 3 and negative 6. So we have 4, 3. Let's graph that. We'll go over 4, up 3. Okay, my x is 4, my y is negative 6, over 4, down to negative 6. Now we can start to see that straight up and down line forming itself. Okay, whenever we have an equation that is x equals a number, you're always just going to have a line going straight up and down, going through that number, which is 4 in this example. Another thing we can do is look back at the worksheet we did yesterday. Remember, we did a bunch of the y equals problems, but we also did a bunch of the x equals problems. They were all lines just going straight up and down. When x equals 5, it's a line up and down through 5. When x is negative 1, it's a line going up and down through negative 1. X is negative 4, up and down through negative 4. So, let me ask you guys this. Would it be helpful if we made like a great big poster with pictures of these to hang up in the room? Just to like reference. So I am a very visual person. Sometimes things just exit my mind and I need a visual reminder. If I spent some time doing that, would it be worth my time? Would it help you guys?
Yes, ma'am.
Okay, I will do that. I'll make you a poster. I think it'll help. Okie dokie. So, number 4. That is the graph of x equals 4. What is the graph of y equals 3 going to look like?
It'll be the 3 on the y-axis.
Yes, 3 on the y-axis. Negative 6 for x. Okay, perfect. So if my x is negative 6, my y is still 3. And I'll do the same points. If my x is 3, my y is still 3. And here, I can write those points out if that's helpful. We'll call this point A and point B. Point A, that's 4, 3. B, you don't have to label everything all fancy like this. I'm just trying to give you a guide to look at. I'll call that C and D. So point C, negative 6, 3. And 3, 3. Okay, so there's my points labeled in case you're curious. And we're going to connect those dots. Okay, so here are my graphs. Here's my graph. X equals 4, y equals 3. We just have a line going straight up and down and then straight side to side. Where's my intersection? Which point is it? I actually have it labeled. 4, 3, my point A. This is where the lines cross. And look at that. That's what we decided at the beginning. X equals 4, y equals 3. So in our solution, x is 4 and y is 3. And we can see that through our graph. Kind of cool. Do we have any questions on number 4? It's a lot. But I think you guys are really smart. I think we can get this. This is tough stuff. It really is. It's a lot of moving parts. It's a lot of numbers. It's a lot of things to remember. It's like, what do you do when there's not a b in the equation? What do you do when there's not an x? What do you do? Blah, blah, blah. We're going to do lots of practice, lots of guides. I will not move forward until I know we all feel good, okay? I want to make sure that you guys know you're supported. I want you to let me know when you're feeling lost. Let me know when you're struggling, because I'm here to help you. I really am. I don't want to leave any of you behind. Okay. Is anybody still writing this stuff up here, or can we move on? Okay, I'm going to scooch down to number 5. Now we're back to slightly more comfortable equations again. We have y equals negative x plus 3 and y equals x plus 1. Somebody guide me through graphing the first equation there, negative x plus 3.
Y 3.
My y-intercept is 3. You are correct. Okay.
-1.
Good. Since I have negative x, it's really negative 1x, so my slope is negative 1. If you wanted it to be a fraction, you could also say over 1, but both would be right. So let's graph this first. Where's my first point?
3.
3, x or y-axis?
Y.
Yes. Y-axis for y-intercept.
Go down 1.
Go down 1. And then what?
Over 1.
Over 1. Good. So there are my 2 points, and I'm just going to create a couple more points for my own peace of mind. And let's connect these dots. So here we go. There's my first line. That's my y equals negative x plus 3. How about my second line? 1. What's that?
That would be the Y.
Yeah, that's going to be my y-intercept. So I'll start up 1. And what's my slope?
1.
1.
Over 1.
My slope is 1 because I have 1x, or 1 over 1. So, guide me to my next point from 1.
Go 1 down.
1 down?
Or no, go 1 up.
1 up. Good. And then
1 over.
1 over. Yay! And we're crossing right through that point there. That's really good. So, sorry. We're going to connect our dots. Okay, and what is our solution?
2 and 1. Or 1 and 2.
Yes, 1 and 2. So remember our intersection where the lines are crossing, that is our solution. We just find the coordinate. I see on the x-axis, this point lines up with 1. So my x value is 1. And my y-axis, it lines up with 2. So my y value is 2. And that is our solution, 1, 2. Not so bad. It's not so bad whenever they're in slope-intercept form. The other ones are a little tricky. I will give you guys that. They are tricky. Okay, can we look at number 6 now? All right. So, number 6, y equals x minus 2, and y equals 2/5 x plus 1. Let's graph the first line. Y equals x minus 2. Where do I start? Say it again.
2 negative Y.
2 is my, or negative 2 is my y?
Yeah.
Okay, perfect. Negative 2 is my y-intercept. So we start at negative 2. And
1 over 1.
good, my slope, I have 1x, so my slope is 1. So starting from -2, where do I go?
Up 1.
Up 1 over 1, up 1 over 1, up 1 over 1. You do that as many times as you want. And we'll connect the dots. Okay. Now let's graph the second line. Y equals 2/5 x plus 1. Who can guide me to graphing that one? Perfect. Our y-intercept is 1.
Our slope is 2/5.
Yes, and our slope is 2/5. So we'll start at 1 on the y-axis. And our slope is 2/5. Yes.
And then run 5.
Yes. So I'm going up 2 over 1, 2, 3, 4, 5. There we go. There's our second point. Now, this is definitely one where it is important on that first line that we made sure our line was accurate. Since we had 2 points really close together, our slope was just 1. If I accidentally had my line tilted too far in a certain way, my intersection might not line up properly. That's why I will say when your slope is 1 or -1, it's never a bad idea to do more points than just 2, just to be certain, just to be as accurate as you can. So, I'm going to connect my dots. Oops, that wiggled a little. Okay, there's my second line. What's my solution?
3 or 5 over 3.
5 over 3? Your numbers are right.
5 over 3.
Yes, 5 is my x, 3 is my y. It's the intersection. My lines cross right up here at x equals 5 because I can trace it down to 5 on the x-axis. And my y is 3. I can trace over to 3 on the y-axis. Very, very nice, guys. Okay. Do we have any questions about any of the problems on this page? Now, before we do something else, I want to ask you guys a bit of an open-ended question, and I want you to answer honestly. I just want to know what I can do to help you guys as a teacher. I can already guess that for sure number 4 is one of them that y'all would like a little more look at. On this page in general, what problems did you find the hardest? Which ones did you guys struggle with the most?
The challenge ones.
The challenge ones, 2 and 4?
Yeah.
Do we all agree with that? Okay, what do you guys think was the part that made it feel the most challenging? Do you think...
I just got confused at first because I didn't move on from the X.
Okay,
Looking up X.
so like on number 2, are you talking about, or number 4? Okay, looking at 4. So you said you got stuck on the X part?
Yeah, because when we were plotting, I forgot to move to the Y instead, so I just stayed on the
Oh,
instead of moving to the Y.
that makes sense. That totally makes sense. So I am thinking, honestly, what I notice with these problems is it's not that you guys don't know how to do it. I think you do know how to do it once I give you the little reminder. I think you guys are having the most trouble with knowing where to start. When you see it, maybe tell me if I'm wrong, but the sense that I get is you look at this problem, you think this is not in slope-intercept form. What on earth do I do? Where do I start? Is that kind of what you guys are feeling when you see these problems?
For me, yes, because when I look at the problem, I always look at, so it's in a regular form, I look at the end of it, and I know that's where I start.
Right, and this one there isn't really an end. Right, especially on the x equals equation, because you think, okay, well 4 is at the end, so that's my y-intercept 4. But since it starts with x equals instead of y equals, it's like what do you do? I get that. I totally get that. So I wonder, I'm thinking what might be helpful for you guys is maybe I could figure out some sort of guide where we can look at all the different types of equations that can be graphed, and you can have it all kind of in one place, so it's not like, okay, well, what day did we do this? Oh my God, like, I don't want you guys to be panicking, flipping through your papers. I would like to get kind of one centralized guide so that everything we need is all in one place. Okay, so that's helpful. Let me make a little note of that, and I will make sure to work on that. And I think finishing this worksheet, that's a really good stopping point for us. It is 10:13. I would like for you guys to just take a little break early today. Normally we wait until about 10:20 or 25, but I don't want to get us started on something and have to cut it off after 5 minutes. So 10:13, I want to give you guys about 25 minutes. So I'm bad at mental math. What would that make this? What is that, like 10:40? Okay, let's say we will start kind of trickling back in around 10:35, 10:40. We'll get officially started back up at 10:40 unless everyone gets here earlier. And we will come back again. So guys, just feel free to take a break, take a breather, bathroom, drink, run out to your car, do whatever you got to do. And I will see y'all in about 20-25 minutes. Okay, so we are back from our break. And based off of what we talked about in the first half, I think what would be really good for us to do today is just lots more practice with some of these equations that we're not as familiar with. So I would love for y'all to get some graph paper out. I went and just grabbed some copies of these pages. There's lots of them on that wood shelf at the front of the room. You're welcome to take notes in your notebook if you prefer that. However, we're doing a lot of graphing right now, so I like to have the graph paper. It helps. And I'm going to label this as my day 17 notes. That's what today is. February 11th. So, Algebra 1. We're in Unit 2. Day 17 notes. And it's Tuesday, February 11th. Okay. And I guess I'll write my name. I never write my name on here in front of you guys. That's me, Taylor. Okay. All right. Let's look at some y equals equations. Let's look at some of those first. So I'm going to zoom in to one of my graphs, and we're going to draw a few lines on the same graph. And hopefully that will give us a little guide to look at for our y's. And this won't count as the big guide I'm planning on making you, just some extra practice in one place today. So I am beside my first little graph over here, gonna write y equals number. Okay. And then under it, I'm going to use some colors today. I'll use a green, maybe a pink, maybe a blue, maybe a purple. Just a couple different ones to kind of differentiate what we're doing here. So I'm going to start by giving us an equation like this. Let's start at y equals 5. So remember, on an equation that starts with y equals, we can think of this as being an equation in slope-intercept form. It could be y equals mx plus b. We could look and recognize that I don't see an x, so I don't have a slope. I'm just given a point for y. Or I could just think about it like this. I like to think of it this way. When I have an equation that's just one letter and one number, there's no other variables, no other information, what this equation is telling me is that I am going to put this number 5 on whichever variable. In this case, it's y. I'm going to put a point on that axis to start. So if y equals 5, I'm going to mark 5 on which axis? The y-axis, the one going up and down. So I am going to look for 5 right here on the y-axis. Okay. So here is where I start. Now, if y equals 5, it's not giving me anything for x. This just means y is always 5. Y is always 5. So, no matter where I go, my x can move. My y cannot. It's not ever going to go higher. It's not ever going to go lower. It's always going to be at 5. So, what I'm going to do with that in mind is I'm just going to mark all the other points where y equals 5 on my graph. Y is 5 in all of these places. Y is not equal to 5 anywhere else on this graph except for through this line. And so we're going to draw a line going straight through it. At y equals 5. Right there. So here's that line. And this is why I'm going to use colors, is I'm going to put a couple of different numbers for y all on the same graph so we can see the difference. The line will always look the same. It's just going to be moved in a different place, somewhere up or down. So if this is y equals 5, what would my graph look like for y equals 2? Up on the 2 on the y-axis, yes.
Out, left and right.
Yeah, left and right all the way across. All I know from this equation is that y equals 2. I am not given a value for x. It doesn't tell me to go up anywhere. It doesn't tell me to go down anywhere. It just tells me that y is always 2. So we could mark all the places on our graph where y equals 2, which is all of these places. And we'll just draw a line going through all those points. Now, you don't have to mark every single point. I'm just showing that every point, any of them will work. So now we've got 2 different y equals a number equations shown. What about y equals -3? Yes, I'm going to go to -3 on the y-axis. Out both ways, yes. Y equals -3 means y is always -3. So no matter where I go, to the left or the right, my y stays the same. -3, no matter where I go. And I will connect all of these dots. And one more for good measure. How about y equals -6? What's that one going to look like? Perfect. On -6 on the y-axis, and that -6 is always going to be where y falls. It goes straight out to the left and right, and we connect the dots again. Now I'm trying to think of some like silly way to help us remember which one goes straight across and which one goes up and down, because I feel like I usually have the easiest time remembering things when I can come up with some really weird way to think of it. I think I might have an idea, but before I share that, let's do some x equals graphs, and then we'll talk about a good way to remember it maybe. So here are lots of examples of y equals. I'm actually going to make this a little bit thicker so I know it's kind of like my heading. Y equals a number, and these are all little examples of that. And now to the next graph, we're going to do x equals a number. So let's start with x equals 5. If my equation says that x equals 5, we know that my x value is always 5. X equals 5 means x is always 5. Where could I put a point to start with?
We got the big circle on the 5, and they go up and down.
So let's see, you mean 5 on the x-axis?
On the x-axis.
Yes, so right here. And then you said up and down?
Yeah.
Perfect. So this is the exact opposite of y equals. When we have x equals, now it's telling us that x, no matter where I put a point on my graph, my x value has to be 5, meaning I'm always going over to the right 5. So I only have wiggle room to move up and down here. I cannot move left and right because I'm anchored at 5 on the x-axis. So it's just going to be a line going straight up and down. There's my x equals 5. What about x equals 2? Perfect. 2 on the x-axis. And go up and down. It can be anywhere on the y, but x is always 2. Good. Okay, so x x is 5, x is 2. Lines up and down. Let's do x equals -3. Where would I start for x equals -3?
-3.
Good, -3 on the x-axis.
Up and down.
Up and down, good. And I'm sure you guys already see the pattern. Once you are able to begin to recognize that an x equals line is always just straight up and down through the number they give you, and y equals is straight side to side through the number they give you, these start to become the easiest ones to graph. I think it's just learning to recognize them is probably the hardest part. But they become pretty familiar pretty quickly. So last but not least, let's do x equals -6.
Negative x on the x-axis.
Perfect, -6 on the x-axis.
Going up and down.
Going straight up and down. Beautiful. That is perfect. Okay, so here are some graphs. Now, I am just trying to think to myself, if I knew my mind was going to go blank and I was going to forget all of this, what is something I could do to remember it? Now, I'm going to tell you what popped into my head. If this is ridiculous to you and it doesn't help, you can ignore it. But I'm just trying to think of what might stick, what I might remember. So, for the y equals equations, I know I'm going to have a line that's flat, laying on the ground. It's laying on the ground. So I'm going to think of the y as, it's like I've got a guy, and stay with me. I've got a guy laying down like this. He's laying on the floor. And the y is like he's really lazy and somebody's asking him to do something. He's saying, hey, graph this line for me. And he's saying, why? He's too tired, he wants to lay down. Why? So he's going to be laying down. Your y equals is going to be flat, laying on the ground. He says, why? He doesn't want to do anything. My x equals, we've got this line going straight up and down. I'm going to imagine that this is like a roller coaster. And we're about to get to this big drop. Let's see. This big drop on the roller coaster. I'm not an artist, guys. I never claimed to be. He's about to go down this crazy steep drop. And he is excited. He's so excited to go straight down. So, maybe this will help. Maybe not. But I can think of my really bored guy saying, why? I don't want to do that. My y equals is going to be a flat line going left to right. My x, it's like going down a steep roller coaster, straight up and down. He's excited. He's so excited. So it's straight up and down. So that might not mean anything to you. It might not help at all, but it just popped in my brain. I thought I'd share it. If it does help, wonderful. If not, you can ignore it. But there is my 2 cents on that topic. So, does seeing all these graphs laid out, does this help a little bit? Good. Yay.
I guess why I got confused earlier with it is because y is the up and down normally.
Yes.
Y goes up and down on the axis.
Right.
So I was confused why we're going left and right on y.
Mm-hmm.
Up and down.
And that is something that I personally struggled with so much when I was in high school, is it didn't make any sense to me. My y-axis goes straight up and down. Why would a y equals equation go left to right? That makes no sense. And the reason for that is because the y-axis goes straight up and down, in order for us to have a line going through it, it has to go left to right. Same with the x's. Even though x goes left to right, the axis does. To go through that line, we go up and down.
Maybe it becomes a diamond whenever we're like finding our coordinate on y.
Uh-huh.
It doesn't have to be on 0.
Yes.
It can be any of that number.
Yes.
Numbers are not calculated.
Well, good. I'm glad that helped. Yeah, I just like to think of it that way too, you know. If it's y equals 5, for example, it could be 5 or 0, 5, but it could also be y is 5 on any other point. Absolutely. Well, good. So hopefully this helps a little. And let's see. I wonder what else we were struggling with today. How about we look at some equations where we have y equals a number x, where there is an x, but there's no b, no y-intercept. So below that, I'm going to write y equals mx. Y equals mx. So in this case, we don't have a b. We don't have a y-intercept. That's a lot like the problem we did on number 2 on our do now, that problem question. We had y equals 3x. We added plus 0 because if there's no b, then our b must be 0. So when we have, for example, let's put y equals 5x. Let's try that first. So normally we're used to looking at the number at the end of the equation. That'll be our starting point, and then we use the number next to x as our slope. Whenever we don't have that number, we can think of it as what I showed you earlier, where y equals x is that line that goes right through 0. If we're not given a starting point of plus 2 or minus 2 or minus 10, plus 10, if we don't have that number at the end, our starting point is 0. It's 0 unless they tell us different. So we can make a little note here. I'm going to say when there is no b in the equation, or no plus something, no minus something, our starting point is 0, 0. We just start right in the middle, no matter what. Then all we have to worry about is our slope. So for all of the graphs that we're going to do here, our starting point will be in the middle, always. So if I have the equation y equals 5x, and I'm starting at 0 because I don't have a b, there's no y-intercept, where would I go from my starting point here?
Up 5
Yes, up 5 for my slope
and over 1.
and over 1. And this would be y equals 5x right here. What about y equals 2x? Where is my starting point?
0.
0. There's no y-intercept there. that's written. There's no B, so our y-intercept is 0. So I said that wrong. It's not that there's no y-intercept, it's that our y-intercept is 0. So we start at 0. And where would we go from here?
Up to
Up to
over 1.
over 1. Up to over 1. Good. And we could continue our slope if we really wanted to. You could keep going up 2 over 1, up 2 over 1. You could even go down to left 1, down to left 1, to just continue that line if you want it to be accurate. And we'll connect our dots. And something we might be able to notice already with our numbers here and these equations I've given you, y equals 5x, y equals 2x. The higher the number is for your slope, the steeper your line is going to be. When your number is a bigger number, you're going to have a steeper slope. The only way to get a less steep slope would be for us to have a fraction as our slope. So for example, let's give you another one. How about y equals 3 over 4x, 3/4 x. Where would our starting point be for y equals 3/4 x? 0, good. And where would we go from there? Perfect. Up 3 over 1, 2, 3, 4. 3, 4. Okay, I'll connect my dots. You can start to see here what's happening with our slope is it really just it changes the angle that our line is going at. 5x gives us a super steep slope. 2x still pretty steep, but not as steep. 3/4 x even less steep. The smaller the fraction, the less steep your slope ends up getting. But since there's no b for any of these, that starting point is always 0 for all of them. Let's do one more like that so we can see even more of a comparison. I'll give you a negative slope this time. How about y equals negative 3x? Where would I start? 0. Good. We're going to start at 0. And where do I go from there? Down 3. Over 1. Good. And I will mark my points. And if you're wondering where on earth did this point come from, all I did is I was using the slope again. So to find from 0 over to down 3, negative 3 over 1, here's where the second point came from. The one up here, I just did kind of the opposite of the slope. Instead of down 3, 1 to the right, I went up 3, 1 to the left. Because when you draw your line through your points, you'll see that slope continues. We will go through that line and that point that I made there. Okay. So there's negative 3x. Y equals negative 3x. Just some more examples. It looks kind of crazy when they're all bundled together like that, but that's what's happening. We can see that the only thing we changed about each of these lines was the slope. That was the only thing that changed. Starting point stayed the same every single time. Okay. and let's do one more little section of graphs. And this time, instead of our slope changing, we're going to have our y-intercept change. So these will be y equals x plus b. So this is the one that you're used to seeing. Y equals mx plus b. I didn't put m there just because in all of these scenarios, I'm going to have our slope be 1, just so that we're only moving one variable at a time. So, for example, I will give you y equals x plus 4. I have y equals x plus 4. Where would I start?
With a point on 5 on the y-axis.
Point on 5 on the y-axis?
Yes.
Okay, so where did you get the 5
Oh,
from?
4, I'm
Oh,
sorry.
that's
Yeah.
okay.
Yeah.
4, you're right. Point on 4 on the y-axis, that's our y-intercept.
Yeah, and then you go up to 5 and over 1.
Yes, you're right. Then our slope is 1, so we go up 1 to 5 over 1, and here's our 2 points. You could continue the points. It's okay if you don't, but it will give you a more accurate looking line. And we will connect these dots. So there is our y equals x plus 4. Quick review, what would this mean? Y equals x.
0.
Plus 0. That's really what it is. I'm going to write in parentheses plus 0. Okay, so if I have y equals x, we know it's really x plus 0. Where would our starting point be? 0. And our slope?
0.
It would be
Up 1 over 1.
1. Good. Up 1 over 1. Up 1 over 1. 0 is the magical number that can make letters disappear. We remember that. If we don't have an x in our equation, then the number in front of x must have been 0. If we don't have a b in our equation, b must be 0. So we're going to trace, connect the dots. Okay, there's my y equals x, and it goes right through the middle. I gotta throw that little marker away. It's running out of ink. And we'll just do one more of these. How about y equals x minus 3? Yes, thank you. Negative 3 on that y-axis. That's where we will start. And then what? Good. Up 1 over 1. Up 1 over 1. There we go. So we can see what happens to our line, whenever our B changes, the line doesn't change, it just moves up or down. We can see when our M changes, like in the previous problem, it doesn't move our line up or down, it tilts it in a different direction. So M, the slope, gives us the tilt. B, the y-intercept, gives us the height. So we can start to kind of recognize what those variables are actually doing to our graph. It changes the shape of it. It changes how it looks. So, that was a little bit of an exploratory activity there. Let's see. Here's another thing I saw during the break that I thought maybe you might want to take a note of. It might be helpful. I saw somebody label their B and their M like this. Your B is your y-intercept. B is for begin. You start with your B. M is your slope, your rise over run. M is for move. Tells you where to move next. So if B for begin and M for move is helpful to you, maybe take a note of it. Even if you don't, keep the note, sometimes just writing something down makes it stick in your brain a little better. Never hurts to do it. All right. B for begin, M for move. I'll put that up there for a minute. Okay. I'm sure you guys are sick and tired of graphing things. I'm killing you. Okay. I am going to give you something that I'm hoping feels like a break. Let's put these graphs to the side. This is our page 1 of notes for today. And we're going to take one more page of notes, this time not on graph paper. Yeah, I wish. It'll be lunchtime soon though. So, this will be page 2. Page 2, day 17, notes continued. Okay, and I'm going to pause this while I grab a few notes of my own, and you guys take your time getting your stuff out and ready. All right, so let's look at some of the things we have been talking about for a little bit of time here. And I am going to write a title. This is probably going to be the easiest thing that we learn in this unit today. So, I'm going to use a different color. It's too light. This is how to find slope. How to find slope on a graph. So, there may come a time, and I'm not going to say may, there will come a time that I will ask you a question such as this. I will say, I'll show you not an equation, I'll show you a line that has been graphed like this. And I'll say, without giving you the equation, what's the slope? So here's a quick and easy guide to doing that. We know that slope is just rise over run. So that's how high up over how far over we go. So whenever we are finding slope, all we need to do is pick 2 points on the line, and you can pick any 2 points. It does not matter if they are super far away from each other or super close together. You just need to pick 2 even points on the line and count the rise over the run. And I'll show you. Now, I lied a little bit. I think we are going to use one more little graph. I'm sorry, guys. But this time I think I want it to be in notes. So I think I'm going to draw it on the paper. I know I gave you a bunch of graph papers, but I'm going to draw mine on here. You don't have to do it the same way. I think that's what I want to do here. So I'll give you an example. Let's say, okay, I am going to do this. I'll make my y-axis and my x. And I'm just going to space out some points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's say on our graph, we have a line that goes through, let's say it goes through 0, 0. So there's 1 point. And then let's say it also goes through, let's see, this would be 1, 2, 3, 4. 1, 2, 3, is that 1, 2, 3, 4, 3. So 0, 0, and this is over 4 on the x-axis, up 3 on the y. So here's a line. So I'm going to show you exactly how we would count, quote unquote, the rise and the run. So this part is pretty visual. If you are wanting to get this written down, just pause for a moment. I will give you time and watch what we do. I'm going to say that these are the 2 points I picked, okay? From my lower point, I like to start from the lower, although it will work with higher. I'm going to start from this lower point, and I'm going to see how far away, height-wise, is my lower point from the higher point I chose. Well, I see that my higher point is right here on my y-axis at 3. My lower point is at 0. So I have 1, 2, 3. I went up 3. So my rise is 3. So I'm just going to write that to the side. So I just counted from my lower point and said how much higher is the higher point. It's 3 units away. 1, 2, 3. I'll give you guys a moment if you're copying things down. You may write. Just labeling my graph. Now from my rise, I counted up 3, and now I am at 0, 3. I'm on the y-axis at 3. And what I now want to decide is how far is my run? How far away is this point? So I can count. And if it feels easier to count down here, you can do that. I see that my second point lines up with 4 on the x-axis. So from my first point, it's 1, 2, 3, 4. Or I could count it up here. If I had lines, it would be a little easier to count. 1, 2, 3, 4. So my run is 4. So if my rise is 3 and my run is 4 and my slope is rise over run, what would the slope of this line be? Three fourths. 3 over 4. Good. So if my rise is 3, my run is 4, my slope is 3 over 4. That one's not as crazy hard to do. We're just counting up and over. The only thing that gets tricky about finding slope with a line is knowing when it's a positive slope and knowing when it's a negative number for your slope. And that's going to all have to do with direction. Since I went up 3 and to the right 4, we have 2 positive values. Let's say I started from my higher point. I went down 3, that's negative 3, but I went to the left 4, that's negative 4. Negative 3 over negative 4, a negative divided by a negative is a positive. We would still get a positive slope there. Okay, but we're just counting the units, rise over run. So, let's look at one where we would get a negative slope. What if I had, let's see, I'll draw one more of these. Does anyone still need this? Can I move it? Okay. So I'll draw that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. This time I will put my first point at y is 3. So 0, 3. And I'll try to make it a little bit easier for us to count it since I'm not using graph paper. I'm going to put my second point right down here at x is 2. So 2, 0. Okay, if these are my 2 points, I want to see if you guys can figure out what the slope might be here just by counting your rise over your run. And if you think you know it, feel free to shout it out. I want to see if anybody can figure it out.
Is it 3 over 2?
3 over 2. Yes. Good, Jenny. Now the only thing different about this slope, first let's go ahead and show how you got 3 over 2. So how did you know it was 3 over 2? Did you start with the top point or the bottom point?
Oh, no, it's positive, so I went from the 0 up to the 3.
Okay, so you started at the bottom, right? And you went up 3?
3.
Okay, so up 1, 2, 3. So we have 3.
And I went,
And then you went over 2?
well,
Okay, and then went over 2. Now your numbers are correct. But let's be careful with our signs, because what you did, Jenny, is you started here
I should have known.
as your first point. That's okay. And you went up 3, and then you went over 2 here, which would actually be a line like this.
Okay.
So we do want to start right on the points. Now this one's tricky. I gave you a tricky one. This is going to be a negative slope. Your numbers are right. So I would start from the point at the top.
Okay.
I would start right here, and I would see how far down do I need to go. 1, 2, 3. Down 3. So since my rise, I went down 3. We have negative 3 as our rise. And our run, we just go from there over 1, 2.
I went the wrong way.
Yeah, and that's okay. That's okay. So now we have 2 for our run. So our slope is negative 3 over 2. Now, getting the numbers right is one of the trickiest parts, so that's amazing that you were able to do that. But here is a good way to remember if your slope is positive or negative. Is I remember that we are looking at numbers, we read problems, we read words, anything from left to right. We're starting on this edge of the paper and going to the right. So I'm going to think about looking at the line on my graph. We'll start with the top one. Starting at the very left side and going to the right, is my finger moving up or down? Up. Since it's moving up, my slope is increasing. It's a positive slope. This is a positive slope. Now this slope, when I start my finger on the left side and I move it to the right of the paper, do I move up or down? Down. Since I move down with this line, we get a negative slope. So rather than trying to remember, did I go down 3? Was that up 3? Is it going to make it positive or negative? I would just worry about getting the numbers and then deciding, is it a positive slope because it's going up, or is it a negative slope because it's tilting down? It's decreasing. Negative. So here's a quick kind of shout out activity. I'm going to ask you if the slope is positive or negative based off of a picture I show you. And I'm going to try to cover up the actual slope. Okay, here is a graph right here. This is not the slope of it. Is this a positive slope or a negative slope? Positive. From left to right it goes up. Very good. Now how about this one? Positive or negative?
Negative.
Negative. It's very steep, but when I go left to right, my finger goes down. Negative slope. It's -6. Good. How about this one? Positive or negative? Positive. As I go left to right, it still goes up higher, just a little bit. This is a positive slope. Let's do one more. How about this one? Positive or negative? From left to right. Do I go up or down? Up. So positive or negative? Positive. Good. Good, good, good. And if you do ever forget that, at the very front right-hand side of the room, there is a little poster that talks about different types of slopes. There should be a picture. I know it's not as bold as most of the other posters, but there should be a picture showing a positive versus a negative slope. So if you ever forget, remember you can look over there. It can be helpful. Okay, so I just wanted to introduce this to you. Give you a little something to look at. Just know that finding slope does exist. We do it by counting our rise over run. We did lots of practice with our systems of equations. I think you guys are getting much better at that. And I think we've learned enough today. I'm going to give you a little exit ticket. You're welcome to wait for the exit ticket. If you want a copy, I'm going to make copies. You're also welcome to write it yourself if you're just wanting to get out of here a little quicker. And if anybody wants any copies of anything that we wrote today in our notes, just let me know, and I am happy to do that for you. Okay. So I'm going to actually ask you to find the slope of a few lines. Now, I know I just introduced this to you, so if you are feeling nervous and need a little help, you can ask me. You can, I'm happy to answer you because this is brand new. So this is our day 17. And I'm going to be writing a few different questions on here. So if you're wanting to write it yourself, I'm using this paper up at the front of the room. If you want to wait, I'm going to have it made for you. Exit ticket. Okay, this is Algebra 1. And as always, this will be due Friday, February 14th at noon. Okay. So, for number 1 and number 2, I'm going to draw a line and I want you to find the slope in parentheses. I'm writing rise over run of each line and I'll give you a space to do this. So you're going to give me the slope and you can write it below there. And remember, if it points down, it needs to be negative. If it points up, it's positive. Okay. So, here's our first line, and I will give you some points to go through. Here's a point, here's a point. This is 3, 0, and -2, -3, And then I'm gonna give you one more. Hello, how are you doing? Good. I'm just making an exit ticket real quick.
Sorry, I gotta go home real fast.
That's okay.
I did that. That's yesterday's.
You're awesome.
So now that thing.
Do you want me to check for you? Are you in a hurry?
I'm not.
Okay.
I just
Let me write this real quick and then I'll look for you. Okay. And our second one is going to be right here. Our first point is negative 4, 3. And our second point is also 3, 0. Okay, so find the slope of both of those. I'm going to make copies for you guys, and that is your exit ticket. If you have questions, please feel free to ask, but that is it, the end.